Hello and welcome. So we're going to be talking about angles of elevation and depression today. It's really an application of using those trig ratios to solve for unknowns. So if you want to know a little bit more about using trig ratios to solve for missing lengths or angles in a triangle, check out the last lesson. Otherwise, let's go right into those applications. We're going to focus more on the setups today than we are going to be the solving. Okay. So first off, when we're looking at this, angles of elevation and depression, the biggest thing to remember is to figure out who's measuring your angle and the horizon coming from them. All right, so whoever measures your angle is where your horizon is, right? So if you're having a pilot up in the air measure an angle of depression, the horizon is from the pilot's line of view if they were to look straight. Right? Your horizon would be in the air, it wouldn't be on the ground. So please, 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 please keep that in mind, especially when you're doing angles of depression. This is like the most misunderstood case for angles of elevation and depression, right? It's really easy to get those wrong. Always work from your horizon, and horizon always works from where the angle was measured, okay? Now, angles of elevation, right? Elevation, I think of mountains. Mountains are tall, right? High elevation, which means angles of elevation are angles that go up from the horizon. If you have an angle of depression, you're down in the dumps, you're depressed, you're going down, right? From the horizon. So elevation goes up from the horizon, angles of depression go down from the horizon. If you remember that much, you're going to be golden for all of these setups. So let's do some reading, shall we? Example 1, from the top of a vertical cliff 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from base of cliff? Okay, so first off, we have a couple of contenders in this. I always draw this out. I'm not an artist, and that's totally fine. We have a cliff. It's a vertical cliff. So there you go. There's my cliff. And cliff is usually on the ground, so there's my cliff. Now I know this cliff just happens to be 40 meters tall. Okay? And it says the angle of depression of an object that is level with the base of the cliff is 34. And we're saying from the top of the vertical cliff, meaning that there's like a person or something, like maybe they're like lying down at the top of the cliff, and they measure an angle of depression. So that from the top tells you that this is where the angle is being measured. That is where your horizon is. And then there's an object that is some distance from the base of the cliff. I don't know where it is. So there's an object over here in the distance, and we are spying at said object. Okay, so there's your triangle right then and there, right? We know that, yeah, there we go. We have a horizon, right? This is your horizon, and angles of depression go from horizon down. And that is a 34-degree angle. That is your setup for this. Okay, and then we just have to fill in what we know about that triangle. So first off, we know this leg of your triangle that just happens to be the exact same as the cliff. So that's 40. Now my goal is to figure out how far the object is from the base of the cliff. Base of the cliff implies the bottom of the cliff. So I want to know from bottom of the cliff to object, or in other words, what I'm really looking for is that distance of the adjacent side to my angle of 34 degrees. Okay, so there it is. There's your setup. That's everything you're looking for. You have the adjacent, you have the opposite, and you have an angle. That's going to be using the tangent function. All right, now this is exactly what we're doing in that using trig ratios to solve lesson that we've done previously, right? Tangent of 34 degrees equals the opposite over adjacent. And then it's just a matter of solving for tangent. So I'm going to multiply by x and divide by tangent of 34 degrees. All right, so those cancel, so get x equals 40 over tangent 34 degrees. Okay, plug that sucker right in. We get, let's see, and then double check you're in degree mode. We are, so 59.30 2 is our answer. Now, it doesn't say anything about rounding here, so you're going to be safest to go at their decimal place, right? But there you are, 59.302 meters away from your cliff is where the object is. Very useful stuff. It's very applicable in a lot of different fields. Honestly, this is the place where I've used the most math outside of high school, or outside of school in general, is actually right triangle trigonometry stuff. So, yahoo! Let's do some more. So, example 2, you have 100-foot wires extending from the ground to 10 feet above the top of a 60-foot pole perpendicular to level ground. Find to the nearest degree the measure of the angle that the wire makes with the ground. So 3 contenders in this picture. We have a wire, we have a pole, and we have the level ground, right? You want to make sure you draw all of that. So we have pole. Pole is 60 feet off the ground. We have ground. Let me do this in a separate color, right? And then we have a wire that is extending 10 feet below the top of the pole to the ground. Okay, so the wire should be connecting to the pole and connecting to the ground, right? That's going to be the hypotenuse of your triangle. Now, this 10 feet below the top sometimes freaks students out. Guys, here is your pole. If I am connecting a wire to the pole, can I connect the wire 10 feet that direction? No, that's not on the pole. You can't connect a wire to a pole using thin air. It's not a thing, right? It's either you connect the wire on the pole, on the pole, on the pole, on the pole, or on the pole. There's nowhere else it can go. So if we're going, here's the top, 10 feet from the top, that means that this is 50 feet, because that's 10, right? And that's your connection of wire. And then we know that wire is going to be connecting to the ground, right? The measure of the angle the wire makes with the ground. All right, so this is essentially like a guy wire. It's like a stability wire. It's helping our pole stay perpendicular, okay? All right, so now we know a little more information. I know the whole pole is 60, but from where the wire is connecting, it's only 50 feet. Now my goal is to find the measure of the angle of wire to ground. Here is wire, here is ground. The angle is between them. All right, so here is mysterious angle. I don't know what it is. All right, now we know one last piece of information. We know that the wire is 100 feet long, which means 100 can go right there. And we just fill in the last information. 50 is the opposite side to my angle. The 100 is the hypotenuse. So in other words, we're using the sine function. Sine of our angle equals our opposite over hypotenuse. Right? And then similar to what we did last lesson, or from there, if you want to simplify that 50 over 100 now, you can. Or if you just want to keep going, go for it. Right? Undo sine with its inverse. And we get mystery angle equals inverse sine. I am going to reduce that fraction. That's 1/2. And there you go. Right? This goes straight into the calculator. I believe we get back 60 degrees, but let's double check. Okay, so inverse sine of 1/2. Ooh, my mistake, 30 degrees. All right, and there we go. So that means to the nearest degree, it was an exact number for us anyways, we get 30 degrees. Done. Right? Huzzah. Set up. Now, next one, we have from the top of a lighthouse, 165 feet above sea level. So we have a lighthouse. Okay, and maybe like here's the top of the lighthouse, right? Maybe my lighthouse has like a little barber pole effect. There we go. Yay! And I know that my lighthouse is essentially 165 feet above sea level. I'm assuming that, it's like this, like, there's my sea. There we go. Okay. The angle of depression to a boat out at sea. So this is another from the top of a lighthouse, meaning horizon has to be from the top of the lighthouse. Right? It's saying from the top, right? the angle of depression, so from horizon down, meaning we're looking down at the sea in some distance, specifically to a boat, right? So we have a boat out at sea, there we go. And that is a 35-degree angle. So essentially what's happening here is I have a from horizon down angle of depression, 35-degree angle, right, from lighthouse to boat. Now, I know this vertical distance is 165 on my triangle, so that's nice. And then the last question is find to the nearest foot, that'll be helpful for rounding, the line of sight distance from boat to lighthouse. So imagine if we had someone in this lighthouse, right? Line of sight implies that you're following the line their eye makes as they're looking out. So they're looking out at the boat, meaning that the line of sight distance, the distance their eyes are going to travel, or like their sight, it's the way I'm describing it sounds a little strange, but it's the diagonal, right? Because the way that you look at objects, you look straight at the object. You're not like looking straight out and then magically down to an object. You just, it's usually diagonals. Line of sight will almost always, I would say 98% of the time, refer to the diagonal in your triangle. Okay? All right, so there you go. Whew. Line of sight distance, x. And then we just go from there. So we're looking at the sine function for this one. We have an opposite side and we have a hypotenuse, right, from our angle of depression of 35. So sine of 35 degrees equals opposite over hypotenuse. Yes, nailed it, right? And then it's just a matter of solving for x, right? Undo division by multiplication, and vice versa, undo multiplication with division. Right, so that means that your x equals 165 divided by sine of 35. So 165 divided by sine of 35 goes into my calculator. And it said to the nearest foot. So I'm not going to worry about 3 decimal places out. We should get 288 as a final answer here. X equals 288 feet, because we're talking about feet here as the measurements were given. And that is the line of sight distance from wherever the top of our lighthouse is to the boat out at sea. Pretty helpful stuff. All right, last couple examples here. So example 4, let's get a little more challenging with our diagrams. Lily is looking at the top of a tall building. So first off, it's actually might be a little more helpful to draw my building. All right, here's maybe the doors, like a double-sided door, like some windows in the building. Yay, top building. Okay, and then we have Lily all the way like away from the building because she's looking at the top of the building. Okay, her eyes are 4 feet above the ground. So we have clearly Lily here standing on the ground. Imagine that I didn't just miss that. Yeah, there we go. Whatever, that's fine, it's fine. All right, and then the angle of elevation is 80 degrees. So question, who is measuring the angle? Lily, right? She is looking at the top of the tall building in the angle of elevation, meaning we should be going up from the horizon. Well, if we're looking at the top of the tall building, the horizon is going to be where Lily looks forward, right? That's our horizon. And the horizon up is your angle of elevation. So there is your 80 degrees. And then the last piece of information we know is that darling Lily is a distance of 12 feet from the building. How tall is the building? So my goal is to find this entire length, right? Height of building. Well, I just happen to know that whatever this distance is, I don't know it, right? That distance plus the little 4 feet of Lily should be the entire height of the building, right? So last piece of information, I know that's 12, so that should also be 12. And there you go. There's your triangle, Okay, your goal is to always end up with a triangle every single time. Make sure that you're putting all that pieces of information together. Take your time to draw it out. All right, we'll set this one up a little quickly and then solve. So we have an opposite and an adjacent. That is a tangent function. So tangent of 80 degrees equals opposite over adjacent times 12 both sides. And we get x equals tangent of 80. That is the x value. We add 4 to it. We get our final answer. So we have 12 tangent 80. That is our x. Add 4 for the height of Lily, and our building should be 72.055. It doesn't say anything about that, so we have 72.055 feet tall. Or it doesn't say anything about rounding. Sorry, I didn't finish that sentence there. But there you go. There is your answer. So make sure you're taking care of that one. If it doesn't say how tall the person is who's measuring the angle, you can assume they're probably like lying on the ground finding the angle, and you don't have to worry about that height for angles of elevation, right? But unless it is specifically stated, then I wouldn't worry about accounting for that height. All right, 5 and 6 are probably the harder examples to go through, so let's go straight into those. So we have an observer in a lighthouse. So back to my amazing lighthouse drawing skills. This lighthouse is not as impressive, but you know what? That's fine. Maybe I'll make a guardrail on this one because we specifically are told we have a person. All right, here's my person. There's the light in the lighthouse. I'm still going with the barber pole effect. I think it looked awesome. Yes. All right, so an observer in a lighthouse, 70 feet above the water. So we have like this and water. Okay. Now our observer sights 2 boats in the water. So we have boat 1 and boat 2. Okay. Directly in front of him, the angle of depression to the nearest boat is 48. Depression to the other boat is 22. What is the distance between the 2 boats? So first off, this is going to be really important. We have 2 angles. 2 angles implies 2 triangles. All right. So first off, the person measuring the angle is the person in the lighthouse. That is your horizon. And we have angles of depression, which means they go from horizon down. All right. So he's looking at boat number 1, which is down here. And we also have boat number 2 all the way over there. Okay. So if I were to just draw a line straight up from the first boat, that's your first triangle right there. And here is our second triangle from the second boat. All right, so triangle number 1 will be right there. And then 2 will be here. Okay, so first off, angle of depression to the nearest boat, right? That entire angle there is 48 degrees. The angle of depression to the other boat, the further one, is 22 degrees. So just make sure you know which one is which. And my end goal, I'm not done until I find the distance between those boats. Okay? Now we know one last piece of information. I didn't write it down here, but we know that this lighthouse is 70 feet tall, which implies that that's 70 and this is also 70, right? We know those 2 distances. All right. So now the next question is, how on earth do we set up our trig ratios? Well, it's actually not as bad. So all we're going to do on this one is we say, okay, well, what I'm looking for is a horizontal distance, meaning the hypotenuse of both of our triangles, right? Those 2 lengths aren't going to be helpful because they're not horizontal distances. The only thing that will be helpful is that horizontal distance, our horizon, when we're looking for this, right? Now, let me just kind of overlay it. This distance between these 2 boats is that same distance there. So remember, we have 2 triangles, triangle 1 and triangle 2, right? Now, if I'm looking at triangle 1, just triangle 1, right, that is the adjacent side for my first triangle. I'm going to call that distance y. Would you agree that if we look at the entire adjacent side for the whole triangle up there, then that distance is going to be the first triangle plus the distance we need, right? Z is x plus y, and our goal is x, meaning if we take the entire distance and take out just the green triangle, the y, we should find out the distance between the boats. Super helpful, super awesome. So let's set this up. So first off, we're looking at the adjacent and the opposite side of our angle, and we're doing that for both triangles, right? Adjacent and opposite of our angle, you're using two tangent functions. So for our green triangle, we're saying tangent of our angle equals opposite over adjacent. Same thing for the other triangle. Tangent of 22 degrees equals opposite over adjacent. All right, now I'm going to work a little faster to solve these just to save a little bit of time. When we get this, we get 70 over tangent of 48 degrees. And then the other one, we get z equals 70 over tangent of 22 degrees. Okay, so this goes right into the calculator. So I'm going to take the whole length, which is our 70 over tangent of 22 degrees. All right, and we're going to take out that green triangle length, so 70 over tangent of, was it 48? I believe it was. Let me double check. It was. Excellent. And that should be the distance between the two boats. Now, I believe it says to the nearest foot, which means that this would round to 110. Yeah, to the nearest foot. So we're looking at a distance between the two boats of 110 feet. Right, because we know z, right, we know y, and we just subtracted those and found our x, the distance between. Alrighty, Godzilla is attacking. The news reporter, Christine, seizes the opportunity to televise the crisis as a booster for her career. Christine gets in a helicopter and takes off to get in closer. However, Christine realizes that she has no idea how tall Godzilla is. So when the helicopter gets 350 feet away, Christine whips out her ever-handy clinometer and measures an angle of elevation to the top of Godzilla to be 37, an angle of depression to the bottom to be 21. How tall is Godzilla? So, a lot of words. Break it down to who's in the picture. First off, the most important thing is Godzilla, right? We're going to go like, right, and then like go underneath. Give me a hot second. I can whip out a cool Godzilla and, but it's Godzilla, so he's like angry and he's like, maybe he's like breathing like plasma or something. Like, apparently it's not fire. I've been told this by multiple students, but there you go. He's like breathing out like scary stuff, and here's his hand, and here's his other hand, and here's his feet. Yeah, that looks terrifying. Whew. Oh man, I would not want to be caught in the middle of that. Okay, so Godzilla. Oh, his eye looks a little, there we go. I wanted the eye to be open. Whew. Okay, and we have Christine in a helicopter. So let's get Christine in there. Right, and she's like piloting the helicopter. So let's, there we go, some hair for Christine. And then we have a helicopter. It's like spinning propeller thing, right? Spinning, maybe we'll do like an old school helicopter a little bit. Yeah. Best helicopter you've ever seen all day. I bet it is. Okay. Now, the reason why we're looking at this, and I'd say, okay, where is the helicopter? Well, if we read this, remember what we said on this one. Two angles implies two triangles. Well, we have two angles, right? We have the 21 and 37. One is an angle of elevation. The other is depression, meaning our horizon, the person measuring our angle, which is Christine, right? That's where our horizon is. And that horizon, we have an angle going up to the top of Godzilla and another one going below to the bottom of Godzilla, right? So we should have two separate triangles happening here, okay? So horizon is where she's at. We're told she's 350 feet away, right there. Okay, our angle of elevation to the top is 37 degrees and depression to be 21. Always work from your horizon. And there we go. And my goal is to figure out the height of Godzilla. That's this entire thing. So if I figure out that triangle and that triangle side for the opposite, heck, that means the height of Godzilla should be those two together and you're set to go. All right? So from there, we have the adjacent side to our angles, and the x and y are actually both opposites to our angles, both angled elevation and depression. So this is another setup for tangents. So the first one we have is tangent of 37 degrees equals opposite x over adjacent 350. There we go. And then our other one will be the tangent of 21 degrees equals opposite sides y over adjacent 350. Right? Times 350 both sides, and you are set for solving. So all we need to do is figure out our x, which will be 350 times the tangent of 37 degrees. Yeah, right? Because multiply 350, right? Same thing for the y's, literally that exact same solving step. So I'm just going to directly add that on. So we have plus 350 times the tangent of, was it 21 or 22? It was 21. There we go. And there you have it. There is the x plus the y, which means our height of Godzilla should be about 398.096 feet, which if we want to go, it would probably be, Godzilla's pretty tall here. I think it'd be more useful to have this in to the nearest foot. So we're going to say 398 feet. I mean, at the end of the day, Christine needs to avoid the blue plasma lasery stuff. So nearest foot's probably going to be good for her rounding. So there you have it. Okay, there you go. And that is like set up for all of these. Just remember one angle per triangle. Okay, and always find your horizon. Angles of elevation go from horizon up, depression from horizon down. You need that horizon. Okay, but that is all there is to it. Thanks for watching.